Hey there, welcome back to another Make Science Easy physics lesson. In this lesson, we're going to be having a look at distance time graphs. We're going to make sure that you understand how to draw a distance time graph and how to interpret the key information within that graph too. So the first thing we need to understand is what do we mean by a distance time graph? And essentially, a distance time graph is a way of representing the motion of an object graphically or visually. So although we can use equations and we can use calculations to work things out, it's often very, very important to show how an object moves with a graph. And there are two types of graph that can represent the motion of objects. The first one, and what we're going to be focusing on in this lesson, is called a distance time graph. In a distance time graph, along the x-axis we have time, and along the y-axis we have distance. The other type of graph is called a speed time graph, and they do generally look the same, but there are differences. So again, along the x-axis we have time, but along the y-axis, unsurprisingly, we have speed. So, despite the fact these graphs are very similar, they do have differences, and it's important that you can recognize the differences because both types of graph are interpreted in a different way. So we're going to have a look at distance time graphs, and we're going to have a look at the patterns you might see. And the first thing that we need to look at is what we call a steady speed. Now, a steady speed or a constant speed is a speed that does not change. And on a distance time graph, a straight diagonal line represents constant speed. So what we can see here is we have a straight diagonal line. So for each unit of time that passes, so for each second, for example, the object is always going to move the same distance. Now, the steeper that line is, the greater the speed is. So a steeper line gives us a faster, constant rate of speed. If we have a shallower line, we have a slower, constant speed. So the gradient of that line is going to tell us the speed. So if we add some numbers in, we've got units for time and we've got units for distance. And the gradient of any graph is equal to y divided by x. So the gradient of any graph is equal to distance divided by time. Now that should look familiar. Speed equals distance divided by time. So the equation is actually the same, but this time it's measured using the gradient of our graph. So in order to calculate the gradient of a graph, we essentially just need to draw a line from any time at all to the line of our graph to create a right-angled triangle. Now, because this is a straight line graph, it shouldn't matter where we draw this triangle, we should always get the same gradient. However, the larger you make your triangle, the smaller the rate of error is going to be. So in this particular example, I've drawn my line at 30 seconds, making this the largest triangle I can. So after 30 seconds, this object has travelled 52 meters. I have distance, 52 meters, time, 30 seconds, speed is equal to 52 meters divided by 30 seconds, which gives me a speed of 1.73 meters per second. Now it shouldn't matter where I measure this from on this graph, the speed should always be the same. Now, it's also worth pointing out that not all objects move, and a stationary object, so something not moving, can also be shown by a distance time graph. So a horizontal line on a distance time graph always shows a stationary object because distance is neither increasing nor decreasing, it is staying the same. If distance is not changing, then there is no speed. So the next thing that we need to look at is a graph showing acceleration. Now this is going to look different to a constant speed. So acceleration is shown on our distance time graph by an upward curved line. Now the steeper the curve, the faster the speed is going to be. And we can show this by drawing tangents against our line. A tangent is a line essentially at a right angle to a point of that curve. Now we can see that tangent C is steeper than tangent A. And we know that the steeper the curve, the faster the object is travelling. So at point C, because we have a steeper line, the object is travelling faster than at point A. Now we can also use the gradient of the tangent to work out the average speed at different parts of the graph. So although the speed is changing, we can calculate the speed at different parts of the graph using these tangents. So remember, gradient is equal to y divided by x. So if we draw a triangle at point A, we can see that 7.5 seconds passes and the object moves 6 meters. So the speed at A is 6 meters divided by 7.5 seconds, which gives us 0.8 meters per second. We can do the same thing at B. Again, 7.5 seconds has passed. This time, 19 meters has been travelled. So we're drawing our triangle again, and we're using speed equals distance divided by time. So 19 meters divided by 7.5 seconds gives us 2.53 meters per second. Finally, we look at tangent C. This time, in our triangle, only 3.5 seconds has passed, but 22.5 meters have been travelled. So we put the numbers in. 22.5 meters divided by 3.5 seconds gives us 6.43 meters per second. So by drawing these tangents, we can work out the speed at different parts of the graph. I just want to take a little break in this lesson to tell you a little bit more about Make Science Easy, and you can visit us at makescienceeasy.com. At our website, makescienceeasy.com, we have complete science courses for biology, chemistry, and physics. These are just like this lesson, but in lots more detail, covering everything that you need to know to pass your science exams. Every course, so the biology, the chemistry, and the physics, has over 65 lessons to it. Every lesson also includes printable resources, question and answer sheets to make sure you've understood, and multiple choice quizzes that you can take online, and you get an immediate grade to see how much you've understood and if you've really learned the concepts. If you want to sign up for Make Science Easy and get access to all these lessons, there is a free trial, but at the checkout, if you want to purchase full access, you can save 50% by entering the code YT50. Now we also know that negative acceleration is the same as slowing down. And this time it's shown by a flattening curve. So instead of the curve becoming steeper, the curve is becoming shallower, and it will eventually reach a plateau. So this is essentially the opposite curve that we see for positive acceleration. Now, we also often need to draw our distance time graphs. So we may be given information about a moving object. So here we have time and distance. So the first thing that we do whenever we plot a graph is we draw the graph's axes. We then add labels to our axes, our independent variable, and an independent variable is essentially the thing that we are changing or is not affected by anything else. So in this case, time. And it will go on our x-axis. Our dependent variable, this is our variable that is changed by the independent variable, goes on the y-axis. So distance in meters always goes on the y-axis. The third thing we do is we add the values, so for time and distance, and we make sure that they are evenly spaced. Every square for most graphs should always have the same value. This isn't true if we're drawing a logarithmic graph, but that's slightly different. For most graphs that have a linear scale, every single square needs to have the same value. We then carefully mark the points with a small cross. So we can see at 0 seconds the distance is at 0 meters. So we mark on a cross at 0 seconds and 0 meters. At 5 seconds we can see the distance is 10 meters. So we travel along to 5 seconds and we follow the line up from 5 seconds until we get to 10 meters and we draw a cross. At 10 seconds, we can see the distance is 20 meters. So at the 10-second line, we travel upwards until we get to 20 meters and we draw our cross. And we keep on doing this until we've plotted all of our points. We can then add our line showing the motion. Now, because this isn't a line of best fit or a trend line, it can just be drawn with a ruler. It can be drawn as a straight line. Okay, so we now need to interpret our distance time graph. We've drawn it, but we now need to see what it shows. So we can break our distance time graph into different sections because different sections show different things. And this particular graph has got three main sections: section A, B, and C. Section A and C both show travelling at a constant speed. We have a straight diagonal line. Section C has a steeper gradient than section A, so the object is travelling faster in section C. Section B shows a stationary object because it is a horizontal line. Now, this graph is fairly unrealistic because it doesn't show curves for any acceleration, so where the graph is changing from section A into section B, it should really be curved. Where it's changing from section B into section C, again, it should be curved. These changes of speed are not instantaneous, but for simplicity, this is how it's often drawn. So, in summary, speed time graphs and distance time graphs are the two types of graph that show how an object moves. On a distance time graph, a straight diagonal line shows travelling at a steady or a constant speed. The steeper the gradient, the greater the speed. Speed is calculated by calculating the gradient, which is y divided by x. A horizontal line shows a stationary object because there's no change to distance. Acceleration is shown by an upward curve. Negative acceleration is shown by a flattening curve. And tangents can be drawn against the curve to calculate speed at specific points. And on a distance time graph, the distance is always the dependent variable, so it's placed at the x-axis. So I hope you now understand what a distance time graph is. I hope you know how to draw one and how to interpret the basic features, and I hope you can calculate the speed on these graphs as well. Until next lesson, keep on learning.